Okay, now we will have a presentation of students on Chapter 8. Mohamed and Team 4 will share their experience and their solutions for Chapter 8.
First of all, hi, my name is Mohamed. So the thing is that we have three parts. We have the individual PBL report, the team PBL, and the bonus part, which is the project part. So I'm going to start with the individual PBL report, then I will go through the group, and I'll finish with with our project. So to start with my individual PBL report, the first thing is the general academic knowledge. So in this section, the professor asked us to kind of summarize what we have learned in the previous 9 chapters. So I tried to use the definitions that are the most frequent and the most useful from each chapter. So starting from chapter 1, we had some terminologies like power set, cardinality, intersection. So by using these terminologies, we got some sort of introduction to the first chapter, which is the set chapter. Secondly, we learned about the proofs, and we had many different kind of proofs, like proof by contradiction, proof by contrapositive, proof by cases, and so on. For chapter 3, we learned about the functions, and the most important part is that we learned about different types of functions, like onto function, bijective, surjective functions. For chapter 4, we had many different notations for analyzing an algorithm, like big O notation, theta notation, or omega notation. For chapter 5, we learned about some number theory. So we learned about something that we have already know from the high school, which is prime number, composite numbers, greatest common divisor, and so on. For chapter 6, we learned about some more detailed principles like the multiplication or addition principle, but the most important factor or the most important thing in this chapter is the inclusion-exclusion principle, which is a principle applied to different sets. And chapter 7, we have learned also something related to programming, which is recurrence relation. In brute programming, we call it recursive functions. In chapter 8, which is my chapter, we learned about the graphs, which is some sort of introduction to chapter 9, which is the trees. So the most important difference between chapter 8 and 9, that chapter 8 is a simple graph, chapter 9 is a graph with no cycle, also known as tree. So this is exactly the same thing that I have already mentioned. As far as for the personal reflection note, so the thing is that from this course we have learned a lot, but the most important thing that we have learned is trying to be organized as much as possible. So it's not always about mathematics, it's not always about how well do you know math. It's also important to deliver that math to others. So even if you know everything, even if you are the greatest mathematician of all time, but you cannot deliver your point to the other student, to the other teammates you have, so it makes no sense. So this is the most important part that we have learned, especially from the flipped class scheme. As far as for the self-evaluation, so the difference between my self-evaluation from October to December or November would be that I became more punctual. So instead of waiting till the last moment to solve the questions, I became way more active. So till October or mid-November, I had posts maybe up to 90. And in 1 month, I doubled these posts, so I am almost at 210 posts on iCampus. As far as for a colleague that helped me in learning, I will definitely suggest Mr. Chinkiz here. So as a freshman and as a foreigner, I've never seen such hardworking guy. So the things that I would really recommend him, that he is too good. We all know that he's too good in programming, but I would definitely suggest him that he should make it way more simpler for the people who do not know programming. So if you could add some comments in your code, which are way more basic with way more simple terminologies, it would be really helpful, especially for the people who know nothing about programming. The next part is the class itself, which is not specific colleagues. So I'm really happy that everyone is trying his best to learn from this class, and I'm really happy that the professor also focuses on the students that are getting behind of the better students. So we can see that till October or November there were many people who were in the F or D section, but professor always tried to motivate them, always tried to give them a better chance, a second chance, so they can improve their final grade. As far as for the importance for this PBL class, as I mentioned earlier, the difference between a PBL and traditional class would be that here you do not actually just apply mathematics, you also try to deliver mathematics to different people. So this is the most significant and important thing from the PBL class. And for the participation part, this is my November, not the December one. So till November I had 192 entries, but maybe I'm at 210, 220, I'm not sure. So what I have contributed to the course of Q&A as me, as Mohammed, on the online lectures, on the online discussion, I think I played a vital role in kind of being the medium between the professor and the students. So there were many times that the professor told us some point, but it was not clear, so I tried my best to make it simple and clear to the students so they can cope up with the faster students. Number of final OK problems is also the old one. I have almost like 85, 86 finalized problem. I will actually now go to the group project because I don't have a lot of time. So for the group project, we are team number 4, as I mentioned earlier, and my team is consisted of me, Mr. Kim Jong-ju, Mr. Chung, Mr. Hyung, Mr. Lee, and I'm trying to make it simple, I'm really sorry. So the most important thing that from the overall project, that the questions were collected by Mr. Kim Jong-ju, and they were finalized and kind of redefined by me. So we had, at the beginning, we had 32 questions. The solved question on the iCampus were 24 questions, but since I don't have time now, I'm gonna just focus on 6 most important questions, and the reasons I'm not gonna solve each. The reason I'm not gonna solve each and every. The reason I'm not gonna solve each and every question would be that the questions are very. Okay. So my team members are right here. Anyway, these are not my team members. Team 4. Team 4. Maybe you want to introduce yourself and your department. Just introduce yourself.
팀사의 김정주라고 하고요. 이번 프로젝트에서 자료를 모으고 쇼티스트 패스에 대한 알고리즘을 조사하였습니다.
Hi guys, my name is Hyungjin Chang and I'm in the software department.
So I'm sorry that not all my team members are available right now. Anyways, moving on to the solutions. So we initially had 32 questions and we solved 24 questions, but the reason that we didn't solve the 8 missing questions is the fact that some questions are really redundant and they are not intuitive. So maybe you could find like 8 sections which have exactly the same thing, like find shortest path, and you will have 10 questions. So what we did, we actually just chose the most difficult and the most kind of new question. So for kind of covering up the 8 questions gap, I don't know how many of you remember, but we opened some sort of discussion portals on different topics. So we could see what is your interest, and based on the interest, we chose our project, which is the shortest path. So for problem number 1, this problem is pretty simple, that we have a graph that is defined by different vertices and edges. and we have to find whether the graph is we have to first find the edges and the vertices. This is not the most important part. The most important thing is we have to find whether the given graph is a simple graph or not. Is it? Yeah, is it a simple graph or not? So before I move on, how many of you know what is a simple graph? No one. Anyways, so a simple graph is a graph that doesn't have any loop and doesn't have any parallel edges. So a loop would be like a circle from V1 to V1. That is a loop. A parallel edge will be from V to 3, like from V2 to V3, then from V3 to V2. So we have like a closed cycle. This is called parallel edge. So if we have either a loop or a parallel edge, we say that the graph is not simple. So in our case, since we have a parallel edge from V2 to V3 and coming back from V3 to V2, we would say that this is not a simple graph, right? Yep. For question number 3. So this question is very simple. We have to draw a bipartite graph. A bipartite graph is a graph that is that has two different sets, and the most kind of important thing about it that each set doesn't have any edges from the same vertices. So if we have this set, let's suppose this is set 1, this is set 2. As you can see, the points or the vertices from set 1, they do not have any edges between them, but they have edges from these vertices to every other vertex from the other subset. So in other words, in the same subset, there are no vertices, there are no edges, but from different subsets, there are all are connected. For problem number 4, this was the most interesting problem of chapter number 8. We have to prove that a given cube is bipartite or not. So in other words, we have to find two subsets. Each vertex in each subset is connected to the vertex of the other subsets, but at the same time, it's not connected to the vertices of the same subset. I know it's kind of complex, but I hope you get the idea from this question. So in this problem, what happens is that first of all, we have to define the points of the cube by binary number. So since we have 8 points, we will definitely need 3 bits of zeros and ones. So we define each point with some 3 bits, and the thing is that we have defined depending on that each adjacent 2 points have a difference of 1 bit. So as you can see here, 0, 1, 0, and this is 0, 0, 0. So there is 1 bit different. And 0, 0, 0 and 0, 1, 1, there is also 1 bit difference, and so on. So as you can see here, we could actually define 2 sets. The first set would be the points which have even number of ones, and the set which have odd number of ones. So the odd number of ones are marked here. You have odd 1 and 1 and 1, and you have 3 which are odd ones, and these are even ones. And as you can see that the sorry, and the odd are not connected to the odd, but the odd are connected to the even. So that's why we have a bipartite graph. For problem number 5, this is the shortest path problem, I guess. Yeah, we have to find whether the graph has a simple path, a cycle, or a simple cycle, or none of these. I have already told you what is a simple graph. So if we start from V1, we go to V2, we go to V3, we go to V4, then V2, then V6, then V1. So we have this closed loop. But since we have went through V2 twice, that's why we don't have a simple cycle. And there's just one more question, which is question number 13. So in this question, we have to find the shortest path from A to I. So starting from A, we have to use any algorithm. So probably here the used algorithm is Dijkstra's algorithm. So we go from A, then we have three different options. Either we go to B, to E, or to H. So let's suppose we go to B. Then after going to B, we have also 3 options, C, F, E. But it doesn't make sense that we go from A to B to E, because we can directly go from A to E, right? So we can discard this one. So we have A, B, C, F. So after CF, we can go to I. So we have two different paths, which is A, B, F, I, and A, B, C, I. And if we calculate the distance, it would be 10. For the second option, which is A and going to E, we have A, E, F, I. This is very simple, which is 1 plus 6 plus 2 equal to 9. And for the last option, which is H, it's the simplest one. We go from A to H and from H to I. 8 plus 16 is 4, and since this is 9, and 9 is less than 14, so the shortest path will be A, E, F, I, and it is equal to 9. For the last part, which is the, I'm going to skip this since we don't have time. For the last part, which is the, the project. So the project, or the in-depth problem that we discussed, is the shortest path problem. And the reason that we discussed that problem is the fact that we have already given you some discussion portals, and we saw that the most kind of frequent answers were on this problem. So the title of our project or in-depth problem is Analysis of Shortest Path Algorithm from Computer Science's Perspective. So since we mostly belong to software department or computer science related department, we thought about going through the algorithms that are inside of our book, which is the Dijkstra's algorithm, and find 2 or 3 different algorithms which have different approaches, different analysis, and try to find the differences between them and the applications of each. So basically the most involved students in this research were me and Mr. Kim Jong-ju. And in here, as I mentioned earlier, that the purpose of this research is to analyze the algorithm from a software engineering or a computer science dedicated way. So I will just go through three main points. Why the shortest path algorithm actually occur in the real world, and what is the difference between Dijkstra's algorithm and Floyd-Warshall algorithm. So the first thing, that why did we have the issue or the problem of shortest path? So in the 1956, there was a programmer, which is Dijkstra, and there was a new computer introduced. It's called Armac, and the company of Armac wanted to show off that our computer can do a lot of things. So they went to Dijkstra and told him, do you have any specific problem that you can elaborate on using our computer? So he thought about using the shortest path problem, which is having different nodes and different graphs and going from one point to the other by choosing the shortest path. So this is the historical aspect. As far as the differences between the Dijkstra's algorithm and Floyd-Warshall algorithm, we have learned about Dijkstra's algorithm. In Dijkstra's algorithm, the weights are always positive. We cannot have a negative weight. But in Floyd-Warshall or Bellman's Ford algorithm, the most important thing is that we could use a negative edge. And the second most important part about the Floyd-Warshall algorithm, that you can actually add a node whenever you want. So in Dijkstra's algorithm, you have a fixed graph, you calculate a path, that's it. But in Floyd-Warshall, even if you have a fixed graph, but at a certain point, if you want to add a new node to it, it will be extremely easy. Even though Floyd-Warshall works in O of V cubed, and Dijkstra works in O of V squared, where V is number of vertices. I think that's all of it. And if you have any questions, please let me or let us know. Please, if you want to add any comment.
네, 챕터 8을 진행하면서 솔루션 된 거, 파이널즈 된 것을 뭐 정리하였고, 쇼티스트 패스에서 다익스트라 알고리즘이랑 뭐 플로이드 워셜 알고리즘에 대해서 조사했습니다.
영어로 하겠습니다. So through this project, I had a lot of fun, especially with the team leader. He was very passionate with his work, and I also did help him in some ways. And yeah, so basically, I really enjoyed being a team member of Mohamed.
문제 풀어져 있는 걸서는 PPT로 정리해서 만들었었는데 사용하지 못해서 좀 아쉽고 뭐 저는 모하메드 하구가 되게 잘해주셔서 되게 좋았던 프로젝트였던 것 같습니다.
Any questions or comments?